Welcome to the LambdaGain Learning Center, Chapter 2, Fiber Design. As we saw in Chapter 1, optical fiber allows the planet to be interconnected. It enables the transmission of large amounts of data across very long distances. What is especially remarkable is the very short amount of time it takes for these transmissions to occur, and as we all know, time is money. But what exactly is an optical fiber made of? What properties make it unique? An optical fiber is essentially a very narrow tunnel which guides light from a starting point to its destination. It does this by trapping the optical signal within its boundaries and pushing it from a transmitting end to a receiving end. Even if the fiber is bent, very little light is lost along the way. An optical fiber consists of three layers: the core, the cladding, and the jacket. The core is the innermost layer of the fiber and is essentially a very thin strand of very high-quality glass. The cladding is also made out of high-quality glass, but its refraction index is higher than that of the core, which allows it to act as a mirror and reflect the light inside the core. The jacket contains strengthening fibers and a protective plastic coating. Light characteristics. The colors we see account for only a small portion of the different types of light that exist. The type of light that is of interest in optical communications is usually infrared light, which is invisible to us because its wavelength is longer than the visible limit. The way light travels across the fiber is determined by many factors. Reflection is the mirror effect that occurs when light bounces off the cladding back into the core due to the cladding's higher refractive index. Refraction is the bending of light as it passes from one transmission medium to another. Propagation delay is the principle that stipulates that rays of light sent straight down the fiber will arrive at their destination faster than those that are sent at an angle. Bandwidth is essentially the maximum amount of information that can be transmitted along a fiber. Velocity refers to the speed at which light travels along the fiber. It is determined by the refractive indexes of the glass used to make the fiber. The physical characteristics of the fiber can affect the optical signals that travel through it in many ways. Attenuation is the loss of signal strength over the length of the fiber due to impurities in the glass. Maximum power refers to the maximum amount of power that can be sent down a fiber. Polarization is the transformation of unpolarized light into polarized light. Unpolarized light, such as that which emanates from the sun, consists of waves that vibrate in multiple planes. Polarization allows only one of the waves to pass through a polarizer. Dispersion occurs when an optical signal is spread out as it is transmitted along the fiber. Noise can be any kind of interference. Fortunately, optical fiber is immune from any kind of noise emanating from outside the system. Thank you for watching the LambdaGain Learning Center. We hope this was helpful in enlightening you on fiber design. Be sure to check out our next chapter, which will cover the different types of fiber.